Welcome to Command Shift Left, the podcast that helps you navigate the treacherous waters of the software development, ops, and security world while also diving into the hot current trends in the industry. Join myself, developer Philip, our co-host Orvice.
Hey audience!
As we battle through hilarious real-world stories, pro tips and hacks for navigating your way around developer security, learning about our Shift Left life, and life stories that have saved our ass. We have two awesome guests with us today, Alan and Jeremy. So we're going to start with a quick introduction for both of them. So maybe, Jeremy, do you want to kick us off and tell us a little bit about yourself?
Sure. So my name is Jeremy Daly. I am the CEO and one of the co-founders at Amped. Amped is a new developer platform that just launched recently to the public, and you can go in and build applications in the cloud without having to deal with infrastructure as code and CI/CD. And actually even thinking about cloud infrastructure. So we launched that the other day, and it's pretty exciting. So you can check that out at getamped.com. That's AMPT.com. And the other thing is I'm an AWS serverless hero. So I've been involved with AWS, building on AWS since 2009. And I started getting involved with serverless in 2014 when Lambda came out. And I've been pretty much all about serverless since then. Love the technology, love the direction it's gone, love the evolution over the last 9 years. I have a podcast called Serverless Chats Podcast, serverlesschats.com, that we talk about, with experts in the field and so forth. We've been on a bit of a hiatus, but hopefully that'll be coming back soon. But more importantly, I write a newsletter called Off by None, offbynone.io. Actually, this month we're celebrating 5 years of writing that newsletter. So every week for 5 years has been a long time. But it's a community newsletter. The idea is to just promote the community, promote the things that people are working on, promote the writings and the tutorials that people are doing and sharing those. And every week we have a serverless star of the week, and we pick out somebody who's doing something really interesting in the community. We try to celebrate that person and just amplify voices the most that we can.
That's awesome. I'm already amped to hear more from you.
Love it.
Yeah, congratulations on the 5-year anniversary, Jeremy. It's nice to have you. And Alan, do you want to give a short introduction about yourself?
Sure. I'll keep it very short. I'm what you may call a repeat entrepreneur. I have an unwavering passion to building companies in the DevOps space. I started this, roughly 10 years ago when I founded BlazeMeter, a load testing company that was later acquired by CA Technologies. I then continued to start Up9. And now I'm the founder and CEO of KubeShark, which is basically Wireshark reinvented for Kubernetes, helping SREs and DevOps significantly reduce their MTTR of production incidents. And super happy to be here on the show.
Excited to have you here. Alon is also a good friend and an investor in the company that both Philip and I work in, Permit. And I just love the name KubeShark. It's so perfect. Like you take Wireshark, you bring it into Kubernetes. It's pure genius. Gold. Love it. And I think now, without further ado, we should jump into our facts. And the first fact for our episode would be my fact. And my fact is that alternate data streams in NTFS is a feature that is turned into mostly being a malicious vector for malware and other maldoers. We often joke as engineers that this is not a bug, it's a feature. But what happens if the feature that you're building, even unintentionally, turns into something malicious? And I don't think we as engineers necessarily spend the time thinking about it. Like, I'm building the feature now, my intentions are good, but someone else can take it dramatically elsewhere. And just to give you a little bit of color about alternate data streams, it's a feature in Windows that enables you for each file to store a different content for the file under different streams. You basically use the colon syntax after the name of the file, and you can store other data there. It's been with Windows since Windows NT. and it was mainly meant to contain more metadata on files. But you can easily see how Trojans and other types of malicious software would use it to hide the data. Because when you click on the file or look at the file, there's only the file, and you don't see all of the data in the alternate data streams unless you look for them specifically. So I'd love to hear from you folks. Have you ever built something that has turned into different causes, turned malicious or something like that?
Yeah, well, I don't know. I don't know if if I can recall a feature that I've built that became malicious. I certainly features that have become abused, or that somebody used something in a way in which you did not intend, and then the next thing you know, it's like doing infinite loops or something where it's sucking down resources. But I think to this point, maybe not so much about it's not a bug, it's a feature. I think one of the things that's interesting to me is what is happening with Gen AI and what people are using that for. So, you always get this thing, and it's sort of happened in crypto as well, but with AI, you immediately have people using these amazing services for malicious things, like, duplicating people's voices or simulating people's voices and making ransom calls and, generating videos that, that look real and, are in fact malicious. So I think with technology, bad actors, will use whatever they can for malicious purposes. So I don't know. I think it's ubiquitous. I think no matter what you do, if somebody wants to abuse it, they will find a way to do that.
I tend to agree.
No, I actually remember at least one. I can definitely imagine. First, I completely relate. It's not a bug; it's a feature. That's kind of one of the main frustrations of any engineering leader, right? Because it's so much fun, but it doesn't do what it's supposed to do. I vividly remember not being able to sleep at night when one of my features was a potentially backdoor to an organization. Like, I started one of my companies when SaaS basically started. I was one of the first to build a SaaS company, at least in Israel. And with SaaS, it's so great. You have one point of entrance, which is at the back end, and it controls so many things back. But if it can also control something at the customer site, so basically you have a backdoor from your SaaS into the customer site, and if it's a large enterprise customer, like a Fortune 1000 customer, so you are now the guard at one of the back doors that maybe is not even supposed to be there. So, it's a feature. SaaS is a feature, that being able to do so many things at one place that is not on-prem, but it can also be a very dangerous one.
I think you're basically talking about like a God mode, in a SaaS, and I think every SaaS company has those. And I think it was it AWS, one of those companies had that problem where, like, because one of their support staff members had access to that higher level of control where they could go into other users' accounts. I mean, that exposes so much. And I mean, I talked about this in the past too, where it's like when you build those types of features where you can access other customers' accounts, you have to have levels where it's like, you give maybe some of your support staff the ability to see some things, but they can't go into the data or they can't make changes or that kind of stuff. But yeah, I think that's a feature that everybody builds, and especially with social engineering attacks and other security concerns like that, they can be very, very malicious or used maliciously if they're not controlled right.
I'd be amiss if I won't take that statement and leverage it to saying that if you're building fine-grained access control into your product, you should really check permit.io out. That it's literally what it's meant for, and to make sure you do it without mistakes. And I kind of wanted to float up this fact in kind of trying to promote good DevSecOps and good engineering. I think a lot of times as developers, we're not aware of how much power we actually have as the products that we're building are being driven into organizations. And while it's extremely hard to avoid something being exploitable, it's basically impossible, you can still make it harder for the other side by adopting best practices. Mainly things like zero trust architectures and having security by design that you bake in first. And I hope that a lot of our listeners would spend their time learning these and as they're implementing features, maybe avoiding creating malicious trajectories that can later be abused. I think this is a perfect time to move to our next fact. And Jeremy, I think that fact belongs to you.
So my fact is that there was a recent Datadog State of Serverless report in which it stated that major cloud providers continue to see significant serverless adoption. And I believe the one of the numbers was that AWS users or Datadog users on AWS, that 70% of their users are using a Lambda function or some sort of serverless service. That is high, but see, that's the fact. But I think the interesting sort of sub-fact of this, and maybe more so a little bit of my opinion in here, is that serverless has become one of those things where, 9 years ago when they first started kind of talking about it, people were like, oh, serverless, yeah, okay, Lambda functions, fine. Over the course of the last 9 years, it's kind of faded into the background in a lot of things. And you see a lot of organizations who are running Kubernetes. Actually, there are people that are running Kubernetes that are leveraging Lambda behind the scene in order to run certain tasks and things like that. That's what we've seen serverless become, as just a tool, or not just a tool, but as a tool that can be used with these hybrid cloud approaches. So whether you're running Kubernetes infrastructure, or you're running other types of containers, or you're still using EC2s and things like that, you see a lot of interesting use cases of serverless where people are spinning up Lambda functions that do administrative tasks for them, or automation tasks for DevOps and things like that, where it will shut down, development servers at night, or it will run, some sort of log aggregation, or kick off some step function workflow that will, run some glue task and dump stuff into a data lake. So I think that's a really interesting thing where, serverless, maybe the buzz has died down a little bit, but I think it's died down a little bit because it's become such an integral part of the cloud. And so many people are using it as, if not, to host everything with serverless, but as an accessory and as a really powerful tool that's plugged into their cloud systems.
That's really interesting. But why do you think that such a huge amount of people are using it? Is it because of the reduced costs of development, or the agility with how you deploy serverless functions and how simple it is? Is there any specific point why companies and people are deciding to use it?
Yeah, I think one of the major benefits, and depending on how you want to carve up serverless, if you're thinking about serverless compute or something like step functions, which gives you, serverless workflows and things like that, I think people are using those because they don't have to tie them to always on infrastructure. So if it's an ETL task or something like that, it's much easier to schedule a Fargate container to run at night than it is to have, an EC2 instance that's running 24 hours a day just to, run a cron tab every once in a while. And you've got the reliability of that. You get the parallelism where you can actually split these things up, and you can do, sort of the scatter gather pattern much more easily with serverless. I think the cost is a huge component of it as well. People talk about cold starts quite a bit. And if you're running an API using a Lambda function, then sometimes you're going to get those cold starts if it's not a very busy API. If it's a busy API, cold starts basically go away. But if you're doing things asynchronously, you're doing change data capture, you're doing, post-processing on a file that gets uploaded to S3, maybe a couple hundred milliseconds of a cold start, no one's going to notice it because it's all async. And these processes are just great to build using serverless technology because you don't have to think about spinning up resources and maintaining them and paying for them. So there's a whole bunch of benefits. And of course, what's great about these managed services, whether it's at AWS or Azure or Google, is that there's this built-in resiliency, right? So that fails, right? There's retries, same things with queues and all kinds of stuff like that, where you have this guaranteed once delivery. So there's just a lot of features of it that make it very, very attractive for people to be able to sort of set it and forget it and not need to worry about that infrastructure grind.
I really like how you describe the current state of affair with serverless. To me, it sounds like we're basically having this technology mature through the hype cycle.
Yes.
So like maybe in the early days, we were like, oh, this is a silver bullet. Everyone's going to do everything in serverless.
Right.
And you just take that Kubernetes cluster, throw it in the garbage. Serverless is your new god. I think that was kind of the vibe for a while. And I think now we're kind of saying it's a great tool, but it's not meant to replace everything. And it can go alongside with other technologies. And you shouldn't be afraid to try it out. And the hype dying down is basically also enabling it. People are less zealous or maybe less frenetic on their opinions about this technology. So this enables more middle ground for people to find themselves and play with this and consider the leadership opinion as not as religiously, essentially.
Right. Yeah. And I think you're 100% right on that. I mean, that, what is it called? The peak of heightened expectations, or the peak of expectation, whatever that is, the top of it. Like everyone's like, serverless is going to replace everything. And look, there's a future that I think the way we think about building apps and who's managing our servers and all that kind of stuff is going to be, is going to change dramatically. That's one of the things we're trying to do at Amped. But I think that we went into that trough of disillusionment when people are like, well, hold on a second. This gets really, really expensive when I'm running high velocity webhooks, right? Like, and I'm running these all on Lambda functions. And why am I paying, $3 or whatever it is per one, per 1 million requests through an API gateway that's just adding latency and not really doing what I needed to do? Like, there's just all these things. And people were like, okay, well, maybe we can't necessarily build everything with this. But I think we're now kind of getting to that early adopter phase where people are like, okay, so I can't build everything with this and get what get the expectations or that performance that I want, but I can put a whole bunch of this other stuff in there and it works really, really well. So I may still have to, do some things, with more traditional technology for now, but serverless helps me backfill all those things and makes me much more productive.
By the way, just to put some history, Lambda 2014, Kubernetes 2016, Docker 2013, right? Yeah. I'm surprised at myself that I remember all these things. Every time something comes out, which is higher than a certain bar, which is basically amazing, you think, hey, this is going to replace everything. But, IT, DevOps, whatever you want to call it, it's huge and it's not meant for one, let's say, piece of land. Usually you'll have multiple, like you'll have Lambda, you'll have Kubernetes, and I'm certain you'll have other things because there's IoT and there are so many things to address. But, having a technology that is mature and proven and, you can rely upon and then you can fortify it so it will be secured and it will be, efficient, all that stuff. I think it's a huge achievement.
Yeah, and I think what was nice about what serverless tried to do, at least initially with Lambda, was to say, the on-demand piece of it, I think, is an interesting part of the cloud. I think a lot of the cloud is on-demand, but I think this also helped try to solve the elasticity problem, right? Which is still a huge problem. So even if you're running Kubernetes or things like that, if you see these spikes in traffic, which again, depending on what you're in, what industry you're in and so forth, it doesn't always happen, but the ability to quickly expand those things is huge, right? So not overpaying for all these resources, expecting maybe I'm going to get 10,000 requests per second, once or twice a day, right? Like you don't have to over provision. So I think that's an interesting experiment there to see how elastic you could truly make the cloud. And I think the other thing about Kubernetes that's really interesting, because I don't want to say I'm not a fan of Kubernetes. Like, I think what Kubernetes did was really interesting. It built the orchestrator that was super helpful. And I felt like what Amazon was trying to do just with their native services was what Google was trying to do with Kubernetes. And then everyone realized, like, okay, Kubernetes is really helpful, but nobody wants to manage it. So then you get GKS, EKS, AKS, like all these managed services to manage the Kubernetes for you, which is it seems a little redundant on AWS's platform, where there's a lot of capabilities there where you can do a lot of that with serverless technology, but not. So anyways, it's an interesting space, because I do agree with you that it's like, not everybody's the same. Everybody's got to pick what's right for them and so forth. But I think these were all interesting experiments around the elasticity of the cloud and going beyond spinning up another EC2 instance, to try to get, and just trying to horizontally shard things or horizontally scale things. It was kind of this interesting approach. But I don't know where I was going with that. But I think I think serverless is interesting. It remains relevant. I think it will continue to grow. I think what we're seeing with serverless databases now and some of the other serverless, quote unquote serverless services that are coming out, that there's still a lot of room for improvement and a lot of interesting things that will happen over the next few years.
Actually, this is, for me, it's a fascinating topic because in the same way you're a serverless fan, I'm a Kubernetes fan. And I can tell you a couple of things. First, having been through the motion of cloud since, it started like AWS started like 2007. Today I'm, full of dates. It was great to begin with. It was amazing. It still is amazing. But at one point, large organization, at least I felt, they were kind of, didn't go along with the AWS taking over everything, and we say goodbye to data centers. The investment, the security, the control data centers provide to you, and you give everything to AWS. So, and I think at that point, and maybe I was imagining, but for me, it felt like Kubernetes was the answer, and Google were pushing Kubernetes because basically Kubernetes is commoditizing everything. Who cares about the infrastructure? Obviously you care, but maybe you shouldn't. Because if you have Kubernetes, then you don't really care if it's EC2 or GKE or whatever, all that stuff. But the fun fact is, KubeShark is decently popular and runs across numerous Kubernetes clusters. And who do you think is the number one vendor there?
Where the
number one Kubernetes cloud vendor we see?
It should be AWS, right?
Yeah, for me it's a surprise. It's EKS, and you would say, okay, Google started Kubernetes, right? They should own the stage these days. And it's basically commoditizing. It's making everything below less important. So seeing AWS so strongly in the Kubernetes domain for me came as a surprise, at least from my perspective.
Well, AWS has a history of taking open source projects and doing a great job at turning them into managed services. So it's not surprising.
I have a question for the both of you, and then a question for you, Jeremy. So the question for the two of you, Philip and I, often in these episodes, we end up talking about uploading ourselves to the cloud, or running ourselves in a simulation. So I want to ask, if you had to choose, would you have your instance of yourself run on serverless or on Kubernetes?
I'd run it on serverless, because then no one would have to worry about keeping it up and running.
My answer is obvious, right? I don't need to actually tell you.
Alarm would also be serverless. No.
Jeremy, another question, a slightly more serious question for you.
Sure.
What's your take on the kind of modern serverless platforms that are layering essentially on top of AWS? So solutions like Vercel and Netlify with their functions. What do you think of those as a haven for people to run serverless?
Yeah, I think that Vercel and Netlify are doing interesting things from a front end perspective. I mean, Vercel very much so considers themselves a front end cloud. I know they have some serverless functions that you can run and some scheduled tasks and some things like that they've added as well. But I think that that's serverless lightweight. Really the more interesting things that you get out of serverless technologies are things like Momento. I'm not sure if you've heard of Momento, but it's a serverless cache. It basically runs, I always forget the name of the underlying cache that they use, but essentially it spins up for you automatically. You can create caches. They're distributed. It's It's a great service. You don't have to worry about spinning up, what do they call Elasticache clusters or running your own Redis clusters or things like that. It just does it all for you automatically. It's just just an HTTP request to do the caching stuff, and it will run in the same regions as your AWS accounts. You can connect it to your VPCs and things like that. Those to me are the really interesting sort of platforms built on top of the AWS serverless services or building their own serverless services in there. Those to me are more interesting. Being able to spin up a Next.js site or one of these other front end sites with maybe a little bit of serverless compute on the back end is certainly a major benefit, especially for developers who don't know how to deploy to the cloud and don't know how to take advantage of those services directly. So I think that's really helpful, and I think that's a step in the right direction. But I think for companies that are serious about building, event-driven applications or something more like that you have to go beyond just where those platforms can take you.
Makes sense. And in fact, this is a perfect spot to move to our next fact. And our third fact is alones. Alone, take it away.
Actually, my fact is closely related to is it a bug or a feature? Product management terminology might be different across different organizations, but the fact I've learned over my life is the distance from feature request assigned to done is much shorter than it goes from done to what I call done.
So can you, for everyone listening, can you clarify the definition? So assign, done, and done.
Yeah, you have a feature request in your, Jira, GitHub tickets, whatever. It's assigned to a developer. Developer goes through the spec, does their best to complete it. They're very happy because they just built something that, and it's done. Is it really done? My humble experience, and again, meaning I was a developer for many, many years, of course, and then turned VPN, CTO, and then CEO. I don't know which part is best, right? But it's kind of, I completely understand the fact of the exhilaration of, it's done, it's working. I can see it. I can, as a developer, I can actually use it, right? I can do 10 different steps that I know of because I'm the inventor of, and it actually works. From that point to the point where the customer, usually we all PLG advocates, right? So the customer doesn't meet the developer. Usually they don't even have time to read the documentation. An application with documentation is also something to be discussed, right? So they don't know the 10 steps for liberation that the developer knows. So this is where it goes from done to done to, okay, it's, you can forget about it and go elsewhere. And that takes time and iterations in my experience.
I think it reminds me of sort of the 90% problem, right? Where it's very fast to get something 90% done, but then that last 10% takes, probably 10 times as long as the first 90% took. It makes me think of like self-driving cars, for example. Like we got so far with self-driving cars, and then there's like that last 10% that is, I just used this analogy the other day, but like that last 10% of self-driving cars is like, don't hit the kid at the bus stop, right? Like, it's like there's like, and it's don't hit the broadside of a white box van, like, that Tesla did. I mean, so these are the kind of things that I totally agree. It's like, this is done. And then you're like, okay, well, it's done. But what else do we have to do to actually make it done, or done, as you say?
I think that's actually a very common scenario that you see in general with new features being developed, because once you classify a feature being done, it's not, I wouldn't always call it a feature complete. There's always things that you can add, right? Like you've mentioned. And it's almost very hard to sometimes establish where you would end and classify something as being fully complete in your mind, where it could have also this and that on top of it and another thing, and then that will make that feature much better. But I guess at some point you have to call it that this is satisfactory enough for the time being, and then I assume add all the remaining things as, I guess, another feature to the pile.
A lot of times in the pyramid, when we're talking about the R&D tasks, I really encourage our engineers to think in evolutionary sense. In the end of the day, when we look around ourselves, everything in nature, it always evolved with iterations. Each iteration is always stable and works by itself, but it's dramatically far away from the potential eventual outcome that you have. So, for example, a semi-fish lizard coming out of the sea and a human being going about writing serverless functions, there's there's a lot of to be desired in between them. But if you aim for that smaller iteration and you understand that you're going to iterate a lot more until you get to where you want to have, I think that also creates better expectations. Like, you have a better time as an engineer instead of like being stressed to, I have to get all of it right off the bat and right now. I'm like, okay, let's have something that works. Let's give it to someone. Let's get some feedback. Let's gain some value with the customers, and then we can iterate on it. But recognizing that, yeah, we're not actually done. We're done with the first iteration. And a lot of times I think once people embrace it, it's very empowering, but it's also, I find, very hard for people to embrace it because they want everything to fit into strict boxes and that are very, very clear. And working with kind of gradients is something that people find challenging. I think that's also why a lot of people don't necessarily jive with the theory of evolution. Like, you look at something like the human eye, and it's really hard to imagine how this thing can come out of nothing, how this amazing complexity can come into existence. And but when you think about it, if you start with a bit of skin that is slightly photosensitive, and then you make it a little more sensitive, then you stretch it out, you can see how that gradient can form. And I find that like super, super inspiring. Like, if nature built all of this complexity with tiny, tiny steps every time, stopping to value it, well, I think we could also do so as engineers.
So I that got super deep, super fast about building a human eye or evolving a human eye. But I think that actually one of the things that is maybe, I don't know if it is contradictory to the idea of evolution, but I think it's important to say that whatever you build is most likely going to be wrong, right? So you're going to have the wrong assumptions, you're going to have the wrong inputs, you're going to have the wrong initial feedback or whatever. And what you build, that feature is probably going to be wrong. And maybe not 100% wrong, maybe it's 80% wrong or something like that. But it does need to evolve over time. But features are experiments, right? Everything we put out should be thought of as like, here's a feature that somebody wanted, or we had an idea for. Is it going to work? You don't know until people start using it. And as we talked about with the first question about, or the first fact about being malicious, like, how are people going to use this, right? Maybe they're using it completely differently than we intended them to. And maybe that's a good thing because now we can evolve that feature into something that, has a different type of value or whatever. So I think that's the important thing. And again, if there are people building startups and stuff like that, like we have a sort of a saying at AMP where we're just like, look, just ship it, right? If it's stable, just ship it. It might be wrong, but the idea is like, let's get it out there. Let's see how people use it. And then let's iterate on it and get to something that is closer to done.
Yeah, I think, guys, what you're saying, actually, I completely relate. But it feels like us and many others are afraid to admit product market fit is a miracle.
Yes.
And it's kind of engineers, especially young ones, they expect, okay, I'll do it. It's done. And it will work and it will sell like crazy.
Right.
Okay. And that's not the case. Actually, I completely relate with all analogy with the human, with what's going on here. It took billions of years, right? And millions of iterations. Like, you guys didn't start as beautiful as you are today, right? You started, kidding. But, there were more. So actually, it's funny because when I hire new engineers, I tell them, listen, you have to be a fast prototyper. You cannot fall in love. And refactoring is a great thing. If you can do it often, that's great. Don't fall in love, right? So yeah, I feel like we're on the same page here.
Awesome. I love it. I think we've had a consensus here about something very core and fundamental to what engineering and what maybe even building startup is. And I'm sure our audience are now pondering this and taking it deep into their soul. And as this is sinking into their souls, I think it's a perfect time to move to our fourth and last fact for this episode. And that fact belongs to Philip.
All right. So my fact for this episode is that there is a phenomenon, and I'm not sure if you guys heard of it before or not, and it's called the phantom vibration syndrome. And essentially, it's a phenomenon where you feel like your phone has vibrated in your pocket or on your desk, but actually when you go ahead and you check it, you realize that it didn't happen. Now, I know for a fact this has happened to me. I know for a fact I had a situation where I went to check my phone and, well, there was just nothing there. And there's actually cool, interesting kind of background behind this of where this actually came from, because there are psychologists that, have these suggestions that we have this growing dependency on technology. It's, becoming, almost an essential part of our lives at this point. And, there is a lot of researchers that argue, well, could this be like a modern day manifestation of like an evolutionary fight or flight mechanism that we have because our social lives are so important, or like getting information through our phones is so important that suddenly we have this mechanism inbuilt where we're like, oh, well, maybe I've got something that's important and I felt it, but actually it's not there. So that's an interesting phenomenon that we do experience. So I'm interested to hear if you guys have ever come across this. And then also, I kind of want to leave this with a question, whether this kind of understanding what happens allows us to maybe, and this might be a little bit controversial here, allows us to kind of manipulate someone or someone's psychological well-being when we do develop new software, and how we maybe want them to react to this new software, or maybe how we want them to use the new software.
Well, I'll say right off the bat, I don't think that's controversial at all, because that's exactly what software does, and especially social software and the feedback loops that are built into your phones. I don't know if anybody, if you know, there's an author and a speaker, his name is Nir Eyal, right? He wrote the book Hooked. So I went to one of his workshops many years ago in Boston, and anyways, his book is fascinating because, yeah, there's a feedback cycle where it's like, it's Pavlov's dog, like give somebody, hit the feeder bar or play something and get them to salivate at the bell. I don't know if you've seen the episode of the American version of The Office, but there's an episode where the Jim trains Dwight every time he rings a bell or he plays a sound on his computer to ask for a mint. And then eventually he just starts playing it and Dwight puts his hand out for it. I mean, I think it doesn't take a lot of iterations to build in that Pavlovian response for people. And if you do it the right way with technology, that's why infinite scroll exists, right? That's why, you keep getting those TikTok videos and you keep getting those TikTok videos. And the longer you stay on a TikTok video, it's like, oh, this is the video they like. Show me more of these videos, right? I mean, we manipulate people psychologically all the time with technology. So I've definitely felt like my phone is vibrated in my pocket, even when my phone's not there. Like I live my leg like vibrate. I'm like, oh, I must, and then I'm like, oh, my phone's not even there. So, it doesn't, even if you're fully aware of it, I don't think it's a phenomenon. I think it's by design. And as developers of software, especially if you're doing things with social software on the consumer side, and even more so if you're targeting younger people, you just need to be responsible about that because, kids are addicted to technology. A lot of adults are addicted to technology, but it can be very dangerous, and the power is very, very real.
Actually, I couldn't agree more with Jeremy. I think we are creatures of habit, right? And we as a human race, and it's easy to look at kids, right? If you give them something that is repetitive, their brain becomes, now maybe it's only my kids, I don't know.
No, mine too.
So, and I can definitely think, hey, I really want to get a message, no vibration out of the phone, damn. But, maybe I just missed it and I'm going to check.
I mean, the fact that Instagram and TikTok and, I mean, maybe not Facebook so much, but, Snapchat, things like that your phone right? Or especially with kids, can actually affect your brain chemistry by, giving you that dopamine response, right? I mean, the same thing as gamblers. And the fact that we bake that in now for kids to me, it's super scary.
So you've been talking mostly about the dark side of it, and so I want to do kind of a opposite take and talk about the positive side, obviously. And what I find encouraging in this is basically the elasticity and flexibility of the human mind. So we are basically seeing how our minds can extend into the tools that we use. So no longer is the and there are by the way scientists that think that this is one of the main advantages that allowed us as humans to take over the planet. We don't just use tools; the tools become part of us. There's even if you go back in time, like you think about hunter-gatherers using slingshots or using spears, their ability to use them efficiently is because their minds melded with the tool. And there's a common saying, if you go a little further in time, like into the Roman Empire, like there's a common saying there that the gladius, the sword that the legionnaires used, was an extension of the legionnaire, and they always keep it with them. And I find it very, very exciting because it means even if we delay in our ability to merge ourselves with our technology, so we've got like Elon Musk and other people working on like brain machine interfaces, but we haven't really gotten much. We didn't really have real advances there. But even if those fail, our minds are elastic enough to wire themselves to work with any technology we bring to the table. And I think this is literally what we're seeing with our phones. Our minds are creating maybe step functions or lambda functions to track the patterns coming from that device so we can work with it efficiently. And I think it's coming from our inception as a species. And for me, as a young, basically fresh parent, I see it correlate with the phantom phenomena of a baby crying. So a lot of times I'd hear as if my baby is crying, even though he is not crying. But that's my mind trying to keep tabs on it and have us be as connected as possible, even if it costs us with a few false positives. So I look at this and I see how awesome we are as human beings, and I find it inspiring, even though it can be frustrating at times. And I think on this very positive note, we can wrap up the show. Jeremy, Alon, anything as farewell to our audience?
No, just, super excited. We talk a lot about software and obviously we talked about serverless a little bit. We just launched Get Amped, or it's called Amped, but go to getamped.com. Would love to get people's feedback. We were really trying to change the paradigm of how people build cloud development, or how they do cloud development, how they deliver software. It's sort of a big goal, but we think it's really interesting. It uses a lot of serverless services, but the idea is, again, abstract away that back end for you so you can just focus on the things that you do best as developers, which is build software, as opposed to what maybe operational engineers or platform engineers do best, which is maintain those platforms. So it's a radically different approach, but we think it's pretty cool. We've got some great customers and some really interesting use cases that people are doing with it. So we'd just love to have people check it out and see if maybe you want to join the revolution with us.
That's awesome. Alon?
First, I want to thank you guys for inviting me. It's kind of being with, I like kind of people. It's like therapy, right? And I think it went out in this show. So talking about serverless versus Kubernetes was also fun. As said, Kubernetes is my thing. And I think Kubernetes is, in fact, complex. It's not something easy. But this is why we like KubeShark so much, because if you really want to understand what's going on inside, just kind of open up the covers and see with your own eyes. Usually when you have problems, when you're troubleshooting, certain situations, it can be extremely useful. And to be honest, I feel like technology is our game. And It's kind of very similar to kids. They are having fun with their whatever dolls, movies, phones. We play around with these bleeding edge technologies. So it's a lot of fun, and it's fun talking with other people that are like-minded. Thanks for inviting.
Awesome. Well, Alan, Jeremy, thank you very much for making time to join us on this podcast. It was an absolute pleasure hosting you.
I think this is the perfect time to wrap up the show. If you liked this podcast, tell your friends about it. If you didn't like it, tell your enemies about it.